And we're audible.
And we're audible.com.
This stream is not sponsored by audible.com. Oh my
yeah.
god.
Oh,
Hello, everyone, and
Hello.
welcome back to Teaching Tuesdays with me, AJ Jacinti, and Dean, Jumping Clover Dean.
Nailed it.
Today, we're going to be doing some more Unity fun time.
Yep.
So, Dean's already taking off his clothes.
Peek of what's going to happen later in the stream.
So today we're probably going to be focusing on scripting.
Yep.
I believe Dean has some exercises that we're going to run through.
Yep.
We're going to learn about scripting, classes, C#, all of that fun stuff.
Yep.
So if you have questions, make sure to post them in the chat. We'll do our best to answer them as best as we can. Also, I have a new ticker right down there, right there.
There you go.
Right there. This is super awkward because it's nowhere. It's backwards.
Okay.
New ticker, so make sure to follow, subscribe to the stream. That way you can be notified whenever we go live and do this stuff. Let's get going, Dean.
All right.
Dino.
So, like I said, today we're going to focus on scripting, which is the actual, important, not really the important part, but, to actually do anything actually exciting. Let me just scoop it out. There we go.
You're fun.
Yeah, to actually do anything interesting and unique and original in any development altogether. So whether it be Unity or Unreal or anything like that, you have to know scripting, right? This is kind of this is the bare bones of what video games and any sort of interactable programming sort of thing are all built off of. So that's what we're going to try to focus on today. We're going to go into it to a decent extent, we're going to try to allocate the whole time today just to try to get a better understanding of scripting, just in general. So once again, just to kind of start out, all the scripting in Unity, the main way it's done is through C#, which, for those who don't know, C# is a programming language. It's very similar to another programming language called Java, but C# is like Microsoft's Java, is basically the whole point of that. So, our goal for today, which we can hopefully succeed at, is we're going to try to make a player that can walk around in a space, and there will be enemies. We're going to quote unquote call them enemies, but more just like entities that are just going to basically follow.
Entities.
Great naming scheme.
Love it.
Yeah, so they're basically just going to try to always track and move towards the player no matter where they run. Super basic, but this could be extrapolated to just be enemies chasing after a player, or I don't know, a fairy always following you. I don't know, stuff like that. So this is just this is just basic following, but more importantly, it's more about just scripting in general. So we're just gonna get right into it. So
Get on with it.
So the first thing we're gonna try and do here is we're first just gonna make our basic scene. Last week we did this something very, very similar to that. I'm just gonna do basically the same thing, but I'll go through it again. So to first make a scene, right? We have a basic scene here. This is our basic Unity. If I press play, it'll just play. It'll just show me the sort of basic screen because nothing's really happening. What we really want to do is we want to make a player that can actually move around on like a flat plane. So the way we're going to do that is we're going to go into our hierarchy here. I like to do it this way. There's plenty of ways to do this, but I like to right-click in the hierarchy, go to 3D object, and then say plane, which I just found. Nailed it. So you can see here that I have a plane here. I'm going to kind of scroll in to kind of see it. This is my lovely, kind of grossly colored.
Oh, that is wonderful.
It's an awful color, isn't it? But hard to say exactly what's going on there. But yeah. Oh, one moment. Okay. Yeah. Do that.
Yep.
So we have our basic plane here. There's nothing too complicated as far as how that goes. So one thing I'm going to do first is that this plane is actually quite small in the grand scheme of things. Also, just as a reminder, the way I'm moving around is I'm just using right mouse button and then WASD to actually move up, down, left, right, all that kind of fun stuff, and then Q and E. Yeah, E to go up, Q to go down. So I have this super basic plane and whatnot. So basically, what I'm going to do is to actually make it longer and bigger so that a player can actually walk around much more on it. I'm just going to go over to the inspector here, where you can see all the plane's specific components, and I'm going to go under scale and make the scale 15-ish size. So 15, tab 15. The Y doesn't really matter because it's a plane, so if you look for this plane. If I kind of look at it straight on, it's like basically two-dimensional for all intents and purposes. So yeah, 15 and then 15. So now we got a big old little plane here that's just doing some stuff. So now we have the plane. We have a whole surface. It has a collider here, which is called the mesh collider. That actually allows stuff to actually hit it. So what we're going to do next is we're going to go. This is still the exact same project we had last week. So we've already imported the standard assets and everything like that. So I'm just going to quickly drag in a first-person character. So you can see down this bottom area here, I have standard assets inside of characters, inside of first-person character, I have prefabs, and inside of prefabs, I have FPS controller. So if I just drag that from into here, so I have it down here, so I just do this again, drag this onto the actual scene view, and now that it's here, luckily Unity's smart enough and it knows kind of where it is. So I'm just going to kind of lift this up a little bit, and then if I press play, I can actually look around and move and jump. Now the only problem with this is that because this plane has no actual depth, I can't even tell if I'm moving for all intents and purposes. So what I'm just going to do is just a super basic way to kind of give us an idea of where the heck we are. So I'm just going to make a super basic scene, give it a nice aesthetics. So I'm just going to make a cube. So aesthetic. I know this coloring is just going to bug me. But
Wow, it is really bad.
But we'll deal with that later. So yeah, I'm just going to click on it. I'm going to drag these little arrows to move it around, move it down. Then if you can see up here, all these different tools. So this just lets you kind of move around the scene. This guy here lets you actually move stuff. This one's for rotations. And
did that gentleman come in and hand that drawing?
Yes.
Oh, okay.
But yeah, so we're basically just gonna fully extend out this guy and make a nice little scene that we can all play around in and whatnot. I'm just gonna actually duplicate this as well, so that way we can just have a bunch of them. So if I hit Control D, I can actually make duplicates of things. So yeah. So if I actually just press D, now I can just basically make a bunch of these.
Oh, that lean. They have they have a nice lean to them.
I know. I gave them a nice little lean.
We're in a dystopian sand village now.
What? What? What?
Look.
Fine. You know what? We're going with it. Dystopian sand village is the new motto here.
The new motto.
We'll just kind of drag that guy.
The new.
The new. Do this guy over here. I like this dystopian sand? What was it again?
Dystopian sand village.
Dystopian sand village. Okay, so now they have a couple of these. Maybe I'll just make like 6 more. Just kind of drag them around places. Just to, you don't have to do this by any means. We just want to do this just because.
This is just to give us some form of like, hey, I'm actually moving towards something, and not like, oh, there's no horizon.
Yeah, so I just also hit Control S there just to save the scene. So now if I press play, you can see that when I look around, it's much easier to tell that I'm actually moving because there are objects that kind of give me a sense of like reference. So I have this. I can jump around by pressing space, WASD to move around. I think arrow keys do it too. But yeah, so now we have this stuff. Now we have our basic scene set up. We can actually start doing scripting. So people who are just completely like not aware of what scripting actually is in the most basic of senses, scripting is just a way that the computer, you can write logic that allows your game to do interactable things. So it's essentially just raw logic. If I don't want to use a Minecraft reference, that's a horrible reference.
Please don't.
Okay, I just won't.
Do a Factorio reference.
I feel like more. Okay.
Well, not more people are gonna know do a Minecraft reference.
So Minecraft, the most basic way to think about it is if you've ever used Redstone in Minecraft, like scripting is kind of like that in a super broad sense that you can program. Like Redstone works in a very specific way, and by manipulating that way that it works, you can do a lot of different things. So I will show you guys how to specifically do this. The plan that I'm thinking about here is we're gonna make a kind of enemy. Really gross looking figure. I don't really know. We'll just do something like that and we'll have it constantly be flying towards the player. So the plan here is I am just going to actually do that. So to make an enemy, I'm just going to make it look horrible because, I'm no modeler. So I'm going to make a sphere. That's going to be his head. He's got a great little head here. Then I'm going to make maybe a little capsule for a body. Yeah, this will be nice. Now we're getting fancy.
Capsules.
Here we we go. We'll just kind of go in here. Oh, I gotta.
God,
Here we go. Dean's modeling. Here we go. Let's go.
this is something.
Here we go. That's his little.
Oh,
he's
man.
kind of a hunchback, isn't
He's
he?
got that.
Oh wow.
He's been staring at the screen for way too long.
Let's make his head a little bit bigger.
Oh,
And then something for like a. I don't know. I don't want to go through like this. Will take too long.
This will take very long.
I want to give him something. I mean, let's
Give him some triangle.
triangle hands. Okay. Well, I can't really. Triangles are kind of.
Well, okay, never mind.
We'll give him cube hands.
Cube hands.
So we'll.
But like,
shrink.
no. Here's
Okay.
what you're gonna
Here's
do.
what we're gonna do. Okay.
This is my forte. I'm
Here we
making
go.
things of nightmares.
Okay, let's
So
see
we're gonna boo,
Stretch
and then we're
that
gonna
out.
wow, womp,
Okay.
boo,
Hmm.
and then we're gonna drag that back, clean that up.
Oh yeah, there
Yep.
we go.
Oh god, he blends in.
He
Dean.
blend. I know. I will show us how to deal with that next. Everything. It's almost like everything's the exact same color. Oh, he's spooky. Okay, so
That was last week, Dean.
oh, sorry, we're not in Spooky Town anymore.
We need to make a cornucopia.
Yeah. What?
Thanksgiving. Cornucopias. The little
I'm sorry. I'm an uncultured person. So now here's the one thing though. So it's really great to have enemies, but the problem is you'll notice that like let's just say I actually want to move him into space. I'd have to move only his individual parts, which doesn't make a lot of sense for me just to move them all individually. So to make this a lot easier, what I'm actually going to do is I'm going to right click over here again, say create empty. You use this when you want to make like holders for a lot of different things. This is a perfect example. So I'm going to say create empty. I'll call this guy enemy. And then what I can do is I can actually take his individual parts by holding down control and then grabbing each of the individual parts. So his head, his body, I can't point, but that's okay. His head, his body, his two arms. And I'm just going to drag those under enemy. So by doing this, what that means then is I can just move the enemy holder and then the whole guy will actually move together. I can rotate it too. If I do this, I can spin him around. Everything just, this is the great thing of parenting, right?
the only thing that might screw up is when you scale it.
Scaling, yeah, that can screw stuff up,
Oh,
but
but it didn't.
most of the time it's pretty okay. Most of the time, it can. I do agree. Scaling can sometimes screw things up, but most of the time you're okay when you parent stuff. It's got a very good parenting sort of thing. So once again, parenting means that whatever happens to this top guy up here, everyone on the below is actually affected by it.
It's
So
like when the CEO loses part of his salary, everyone below is affected.
I guess, yeah. Now, something that we should be concerned about here, which we might have to deal with, is because the actual object, these guys here, are not centered in the actual enemy script, that means that if we actually place any one of these enemy holders, they're actually going to be offset. They're going to be like a certain distance actually away from where we initially placed them. So what I'm actually going to do is I'm probably going to have to destroy our little man temporarily. Let me bring our enemy. So our enemy guy is right here. That's fine. I will just specifically, as long as I just zero out basically in the position, if these guys are positioned at 0, 0, 0 in the enemy holder, that means they're at the center of the enemy. So if I actually just do 0, 0, 0, which means that now you can see I've kind of ripped off his head, unfortunately. But I'm just going to do this just so it's a much more effective way to actually get this done, because that means when you place enemies, they'll be placed in the proper position. It won't look like they're just off. 0, 0. I'll have to just do a little bit of an adjustment here. Oops. Scooch that down. I want to make sure he still has a little bit of a hunch. And then the same thing with both the arms. I can just select both of them at the same time and say 0, 0. And then even though this will kind of screw it up, that's okay. So we'll do this. We'll put one arm over like that. And then another arm over like that. Oh, look at him go. He's looking so good. So I'm going to do this. I'm going to say save. Okay, so now we have an enemy, which is great. So we have an enemy. Now we need to actually have him do something. Because right now, if I just press play, he's going to be here. But
He's just a floating man.
he's just a floating man. He can't do anything. I can collide with him, which is nice because he has colliders.
He doesn't move anywhere because he's
Yeah.
not kinematic.
Yeah, so essentially he's just going to kind of be stuck here, and we need to actually have him do something. So this is where scripting is really going to start to come into play. So The way that I'm going to try and structure this is a very common way to deal with a lot of enemies, and you want to have one script that manages them. So I'm going to start by just making the enemy script itself. Just kind of go with me here. We're just going to do this one step at a
It's gonna
time.
be fun.
So the way that all scripts are actually applied to objects is, remember that everything in Unity is a game object, right? This is a game object, all that stuff like that. It basically means that it has the ability to be moved around, scaled, transformed, everything like that. But on top of these game objects, there can be what are known as components, right? So on the light, it is a game object, wherever the heck the light actually is. Where are you? Ah, there you are. Sweet
All
shot.
over there.
All the way over here. So yeah, you can see that, there it is. Yeah, so you can see that while I do actually have this, light here, which is just a game object, there's a component attached to it, or a script, if you want to call it that has all these different features. So the type of light that it is, mode, intensity, all that stuff. So we can do the exact same thing for our specific enemy, where we can give him custom things that he has, so maybe movement speed or attack damage or health and all that kind of stuff like that. So that's exactly what we're going to do. So we're just going to say add component. Now I did a test with this to make sure I could actually do this. So I'm just going to say a new script, and we're going to call this, I don't know, enemy script. So just like I said, make a new script. I just say create and add. So I'm just going to press enter. So now it exists, right? So now there's the script that's actually on him. Obviously right now the script is empty. So what I'm going to do is, if I just double click on this, it's going to open it up on this. I'm just going to say reload, because you don't need to worry about that. So now we're in Visual Studio. I'm actually going to zoom in a little bit so you can see a little bit better. So now we're in Visual Studio. So this is actually where the scripting happens. This is where you do all the stuff. Excuse me. Drink some water.
It's important to stay hydrated.
Indeed. Okay. So I'm just going to kind of go, because the thing about scripting is that oftentimes is a very difficult thing to understand for a lot of people, because it is like another language. You have to understand how the computer can understand exactly what you're trying to do. So just taking it line by line, because that's how code works, right? Each line, so line 8, or let's do it like this, line 9 happens before line 10, and so on and so forth. So everything is just very, goes in a directly straight line. So it's very easy to kind of see that concept, but following code is definitely an acquired skill. So don't worry about it if it doesn't make sense initially. It just takes time. So to kind of explain what's happening in the most basic things, starting from line 1, when you see these using things, this blue using, if a word is in blue, that usually means that, not usually, it means that it's something that's inherent to the actual code itself. So that's not something that we can really write per se. It's something that is built into C# as a language. So using is one of those words that you cannot use for your own things. It has to be specifically for this code. So using just means that there are these giant libraries out that Unity and Microsoft have created that defines how their language actually works, right? So one way their language is defined is by using this thing called system.collections. That includes, I think, stuff about like arrays and some other kind of really basic stuff. I don't know exactly what these things fully contain, but it's just a default when you create a language that you should probably include these, because oftentimes you have to use structures that are built that were created in these using things. They're available to you. You shouldn't try to use all of them, but using some of them is always very useful. System.collections is the same thing. Using Unity Engine is a necessity, because otherwise you wouldn't be able to use game objects or transforms or positions and stuff like that. Like, you need Unity Engine, because that's
What makes it applicable to Unity.
yeah, that's how you get it.
That's how you link it.
Yeah, that's the Unity engine is using the engine, so that's how you're able to do all this stuff down here. So let me get to down here. So classes. And this is a whole thing. So a big part of Unity scripting, and a lot of scripting for game engines, is they use something known as object-oriented programming. That's a whole class. It's literally a class on what that essentially entails. But for all intents and purposes, for Unity development and for a lot of development, programming in their specific languages is about using objects. Objects is a very obscure term of what is an object. For Unity, pretty much everything is an object. Your light is an object, your player is an object, your controllers are objects. So when you make a class, it's a way of referencing to that object and actually applying different features and properties and such to that specific object. It's a way of actually taking an object and modifying it in some unique way. And the great thing about classes is that you can make multiple of them. Like if I have one enemy script, that is one script, but that can be applied to hundreds of thousands of objects if it needs to be. So once again, the most basic senses of what a class is. That's like a whole complicated lecture of what a class really is. I can't do it justice. A professor would probably know it better than I, but for all intents and purposes, at least for now, this is just the holder. Anything inside this, specific public class inside these two brackets, that shows you like what's actually inside of it. Anything inside of those is what you actually kind of entail. So when you have this enemy script, that's just the name of our file. You can see it up here, enemy script. As well as you can see mono behavior. Mono behavior is a built-in function in, once again, the Unity engine that allows you to use these functions called start and update. So in all programming, right, there are things which we call functions. Functions are exactly what they sound. They do something. You call them at some point where you just write them in a line of code, and then you say, hey, I want you to do this thing. So then you'll just do it. So they're just things that will actually execute in the code as the, whole engine is just running and chugging endlessly. So start is one of these functions. Start happens that if I go back to Unity, when I press play, boom, start has run. That's exactly what's happened. That's all it really is. When second you press play, boom, start is actually run. It's really useful when you want to initialize things. I'll explain that in a moment. But I can actually explain to you exactly how this works even better. But first, and then there's update, which update is the fun one because update happens once per frame. So for anyone who doesn't know, how games actually work is, I can explain it probably better if I do this. So if I'm in the thingy, you can see that in this, oh man, it's so in the way. In this upper right-hand corner, there is this statistics panel, right? So what games do, as you can see, there's a frames per second. All this that you're seeing here is all just a facade, right? So it's a number of times per second. If you think of like a normal animation, if you play enough static images on top of each other, it can make it look like something's actually happening. So it can make it look like there's actual movement. You're moving forward, you're moving backward, things are moving in front of you. That's how you actually get this kind of stuff. When in reality, all it is just single images. Now, if you have enough of them all coherently, it can really make it look like you're actually moving. Because, I can't tell that I'm not actually moving in the space, even though in reality, it's just a bunch of frames. And I can prove this point by, actually, I'm not sure how well I'll be able to prove it, but there is this, you'll notice there's this little small thingy here. If I press pause and then play, what this will actually do is every single time I press this, it moves one frame. Obviously, there's nothing really happening, so it's not super helpful, but I can explain when that will be useful. But essentially, that's what that update is doing, is 68.7 times per second. It's just doing a rounding thingy, but however many times per second this update function here, oh, that's Blender, oh my, this update function here is running. So that means whatever you put in here, that whatever code you have running, it will be running that 60, 70, 80 times per second. So, this is where you can see that it can be dangerous to have things inside an update function. Now, computers are incredibly strong and incredibly well optimized, so it's most of the time you don't have to worry about it, but it's just something to bring up. So I can explain the direct reference of code here. So what I'm going to do, first I'm going to press stop so you can just chill. Now is it doing, there we go. Okay, so I'm going to explain how you can directly see what your code is doing. I'm going to give you the single most useful function of all time, in my opinion, in Unity. It's called debug.log. So what this function does is it's oftentimes really difficult to tell if your code is actually running. Because I could be applying this to a script here, but I'll never really know because I can't actually see what's happening in the back end behind Unity. So if I want to know if a function's actually running, if I type debug, and you can see that Visual Studio here, it just helps me out so much. It knows exactly what I'm thinking. If I just press enter, dot, and then I just type log, and I do open parenthesis, and I just type in a message. So I use a string. I'm going to explain all this in much more detail in a moment, but I just say, hello, I have been run. Exclamation mark because we're happy. So, to explain what this is, debug is a class, once again another class, that has a function built into it called log. What this log function will do is in Unity, there is this handy dandy little tab down here called console. If I click on this, You can see it's mad at me because there are 2 audio listeners in the scene. I will fix that right now. There we go. Don't worry about that. So in this console window here, anything that I write in debug.log, or there's actually a couple other things that you can do there, or any errors I get, they will be printed or written to this specific console window. So now that I have this and I have my enemy having this enemy script attached to it, if I press play with this, remember you have to save your classes. If I press save and I press play, you can see that in the console down here, it has actually gone through, and you can see this is a proof that my function has actually worked. It ran through start, it saw this function, it said, hey, log it, okay, I got that. I'll throw it onto the actual console here. So that's something that's super useful. I truthfully think it's arguably the most useful function in Unity at the very least, because it's hard to tell if your code's actually doing something. This is a really, really effective way of knowing, is my code actually running the way I think it should? So that's a useful thing. You got anything to add?
I mean, its usefulness kind of applies. Like this seems super basic. Like, of course, it's gonna run with like the generic like start, but the debug.log shines when you have, you know, like 1,000 lines of code, and you need to make sure that your program is hitting a specific part of that. And by putting it in there, you can check the log and see like, oh, hey, it's not, or hey, it is, and now you have another issue of it's just not even doing the thing that you want it to do. But if it isn't getting there, then you can solve, like, it's just handy in identifying the path that the program is taking.
Yep. So yeah, exactly. So, and I'll show you what update's actually doing now. So if I pick up this specific line, I just cut it out, and I throw it, I have to think about this, and I throw it into the update function, you'll notice now, so you can see currently that this one has a 1, which means that this log was called 1 time, because start only runs 1 time. So make sure I save, because I have a thing about saving. And I press play, you're going to notice that this number down here is kind of going up at a fairly fast rate. It's because that's how many frames have happened ever since this thing has been called. So like every single frame, it is calling that function and writing it to the logs. We're at 600, 700, 800, you know. So it shows you how many times something is actually happening. So it's super duper useful. So yeah, so now that's just the super duper basics of script. That's just like the raw basics of just getting an idea of what your script is actually doing at any given time. So now we need to actually make it do something.
The fun part.
The actual part of making it do something. So the way that I was thinking about doing this is we can just, right now, I'm not going to worry about like making something look at you. I just want to make it so we have a couple of objects that fly towards the player, and they start at random positions and then come back in towards, you know, the actual player, and they will follow the player as the player moves around. So I could just make a bunch of enemy scripts, and I could just instantiate this, which I'll explain that in a moment, and have them all run towards the player. But that isn't really effective, because by doing that, I'm going to make a bunch of these like separate little guys all running all over the place, and I can only control one at a time. And that's just kind of crappy, because I want to be able to control all of my enemies at once. I want to make them all faster or all slower. I want to know what's happening with every single one. So what I'm actually going to do is I'm going to make another script that is going to manage this script. So if I go back out into Unity, I'm going to create an empty... So remember that when you have a script, it has to be on an object. Otherwise, it doesn't exist. In Unity's eyes, it's just like, cool, you have a class, you have a file, that's cool. I'm not going to do anything with it. It has to be actually on an object. In my case, I usually just make an empty object, which is what I'm going to do. So I'm going to say create empty. I'll rename this to like enemy. Oh, that's Denemy. See?
Enemy.
Denemy. Manager. And then what I'm going to do is do the exact same thing I did before. So I'm going to say add component. Scroll down to the bottom. New script. I'm going to call this one enemy manager. So by doing this, once again, I've made a new script. And cool. I can open this guy up when Visual Studio feels ready to open it up. Sorry about that. Yeah, so like I said, it's the exact same thing that's been happening before. They both have something very similar. So now, what I'm going to try to do is I want to have a way for me to reference all these little, you know, smaller scripts, all these specific enemies from one main enemy manager. So that's where instantiation comes in. Instantiation, or instantiating an object, means creating a new version of that object. So the huge advantage of using object-oriented programming is that one class can be in about 80 different places, or more than that really. It can be almost infinite. It's because things are defined as objects. So you can have a bunch of different objects that are just all over the place, all running from the same script that has like this sort of base mechanic to it, right? So what that basically means is that I can create a bunch of these same enemies all over the place. So that's exactly what I'm going to try and do here. So what I first need to do is I need to make sure that my enemy itself like is an actual enemy, right? Because I mean, right now it's just like, cool, it's an enemy script, but there's only one of these, and I won't be able to duplicate this. So that's where prefabs come into handy. So over in the assets, to make my life easier, I'll just make a new, like maybe just a new folder. What should I call this folder? How about the greatness.
Yeah.
It's spelled like a great.
The greatness.
There we go.
Monster.
No, don't you dare. Okay. So what this means now is that I have a folder. That's just for me and just organization in general. So I want to make sure that this enemy here, I want to make sure that like this sort of prefab almost, this blueprint of an enemy, I can duplicate that a bunch of times. So the best way to do that is by making a prefab. Prefab is basically just a container of an object with all the specific components and crap all attached to it. So, and a super easy way to do this is to take an enemy from the hierarchy, drag that into the actual project view, and if you let go, you'll see you have this enemy thing. Now you might think like, okay, that's cool, it did literally nothing. Well, the great thing is now I can just start dragging these all over the place, because now it knows exactly what the heck I'm talking about when I make an enemy. So I can make, however many of these as I want. Every single time I'm dragging this, imagine that in code I am instantiating it. I'm creating a new one. So, and you can see all of them have the script attached to them. So we can do that exact same thing I just did, but in code, which is exactly what we want to do. So now that I have this prefab built, I don't need this one, here. I can just instantiate one myself. So what I'm going to try and do, this will be fun. I'm going to delete this guy, so now he's no longer here. I'm going to go into my enemy manager, and I'm going to try to actually just create one from scratch. So the plan is in the start function, which is probably a good place to start.
Yep,
that's good. So that's a good place to start. So if I just want to make one right now. Just keep it simple. I just want to create one of these prefabs from nothing. Now, to do that, the script itself has to know what it's actually talking about. Like, how does it know I want this specific enemy, not a bird or a log that I've created? So the best way to do that is you can make what's called global variables. So variables, once again, a whole topic. If I want to create any idea of like a data type, so I want to create a number, I want to create an object, I want to create an audio file, all these have to be stored in what's called a variable. Variables, by definition, they can be changed. So you can set and get, and you can do all these cool stuff with variables. So what I want to make is I want to have a variable that can be grabbed from any different position. So what I'm going to do is I'm going to just go with the nomenclature here. We're going to say public, which means that any other script around the entirety of Unity, as long as they have access to this script, they can access this specific thing. So I'm going to say public, and then the thing I want to get, so this is how you actually write variables. You specifically say its level at which it's able to be grabbed, so public in this case, because everybody can grab it. Then you say the data type, that data type being specifically like, is it a number? Is it a string? Is it a game object? Is it an audio source? Is it all this other crap? Is it a light? So you need to know the data type. In our case, it is a game object, right? Because that's an object we want to specifically grab. So I'm just going to type game object, and then I got to give it a name, because when we write code, we need to know like what this object actually is, and we need to be able to do a bunch of stuff to it. So I'm going to just call this like enemy, capital enemy, just so that way I know it is a global sort of thing. And then you have to end everything with a semicolon. That's the way that a lot of programming languages work, not all, but it's quite a common thing to actually have. So I have enemy here, and then I'm just going to say in the beginning, so now that I have this specifically here, and I'll show you what this actually means, because It might seem weird what this actually is, but if I go back into the Unity scene, I wait a little bit for it to think about life, you'll notice now in the enemy manager, I have this little field here that says, hey, I'm looking for a game object. There we go. Okay. Yeah, so now you can see that this is the exact same kind of thing as having a directional light. It's just like a little field that I can specifically access here. So we're kind of coming back from the abstract more into the concrete. So it's looking for an object, right? But currently it says there's no object here. So I can say, hey, I have an object for you. We'll put my enemy in that. So if I drag my enemy from the actual project view into the inspector, now it has a reference to the specific enemy, which is great because, now we actually knows what the heck we're talking about. So I'm going to save over here because, always save.
Gotta keep saving.
Gotta keep saving. And then, now that I have access to this enemy, I can actually create it from nothing. So what I'm actually going to do is there's a function that's built into Unity, which is called instantiate. You can see it just right here. If I click on instantiate, this is a function, right? Now the way that functions are designed is they have an open-close parenthesis. So you can actually see it. This is kind of a blueprint for a function, right? This says what it's returning. In this case, it's returning nothing, so it's never sending any data back. This is the name of the function. And this is what the function actually takes in. Because functions, they're really modular, so they can return back data. So if you send in, they can give you something back. And you can also send them stuff in so that they can actually, fuddle with. Instantiate as a function takes in if you do this, you can see that there's this, sorry about that. There's this field here that says object original. That's just the name of it. It's looking for an object. We have an object. We have our game object. So if I just type in enemy here, and I hit semicolon, I say cool. And then if I go back into Unity, and I press play, you'll notice in the hierarchy, you'll notice there's a guy here. He wasn't here before. And you can actually see his name is now Clone. And if I click on him and I go into the scene view, you can see that I have instantiated him essentially from nothing. So if I unpress play, he'll disappear. And if I press play, he'll come back.
It's magic.
Freaking magic. It's great. This is so cool because this means that you can procedurally, off of nothing essentially, create objects, destroy objects, move objects. Like, this is the power of scripting. It's like you can do so many different things.
Now,
Yes.
Dean, what if the viewers at home want to position the enemy at a different spot where they instantiate it?
That is a fantastic question. So let's just say, for sake of argument, instead of placing the enemy where it actually initially appeared, you want to place it at a different location. So let's just say we could put it at the actual player's location. Well, actually, that's a poor way of doing
That's a
it.
poor way of doing
I could just
it. Make a little platform.
make a little platform and have them go on there. Okay,
Yeah.
we can do that. All right,
Because
so
then you know where the platform's location.
that's true. That's true. Okay, so we'll make a little cube. Put that in the ground. Like this. We'll make it a little bit bigger. Something like that. Okay, so this is kind of where a lot of specific, this is where some trickiness can kind of happen because you have to understand, like, okay, I want to put him on top of here, but where is on top of here, right? Because it's kind of broad. Like, it's here, obviously, because this is where the position is, but what does that even mean? So if you think of a giant graph, Unity is a giant graph. It's a giant three-dimensional graph with an x-axis, which you can see this is red arrow, a z-axis, which is this blue arrow, and the y-axis, which is the yellow arrow. So everything in Unity has to be placed at some position. So in our case, this guy's position is x at 315, blah, 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 y at blah, 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 z at blah, blah, blah. But we don't necessarily have to have him at that position. We can put him anywhere else. So you can see that there's something in all functions, which is really nice, called overloads, which means that the function, it doesn't necessarily have to take in just an enemy. So if I go back out and I delete this, and I do that open parenthesis again, you can see that this is 1 to 10. Let me see that. Hold on. Nope. There we go. Oh, you still, yeah. Visual Studio. Okay, that's fine. Whatever. So basically there's this small 1 to 10 thing, which means that if I click the down arrow, you can see the actual parameters that it's being sent through are actually changing. So this one says like object, position, quaternion. I will explain. Oh my god, that's a whole. Oh my god. But yeah, so if you did want to actually position it at a different location, I could say, okay, I'm okay with that. I can accept that. let's just say I know the position of this object is specifically this 315, 150, or 0.55, and
100.
that would be. So I want to try to place them roughly above that. I'm like, okay, I can do that. So I will need then some sort of holder to say, okay, how do I hold these three values, right? How do I hold this position? There's a really easy way to do that. You also notice that this thing is red. There's these red squiggles beneath it. That means that the compiler, or the thing that actually turns the code into something the computer can actually read, is saying, hey, this doesn't work. I don't like this. If you hover over it, it'll give you an error. It just gives you some, most of the time, stuff you'll be like, what are you even talking about? It's because this line here is not correct. It doesn't follow the strict guidelines that define how all code works. So what I'm going to do is I'm just going to delete that for now because I don't want it to get angry at me. Basically, I need to create this sort of idea of what a position is. So in this case, I'm just going to create what's known as a vector3. So this is, when you write variables, I'm creating a variable here, you have to first give it a data type, right? It's the same thing we did here, where since now that we're inside of a function, we don't need this public thing. So inside of this function, I'm going to create another variable. It's going to be called a vector3 variable. What a vector3 variable is it basically holds a x, a y, and a z. It doesn't have to be a position. It oftentimes is a position. It could be a rotation. It could be a something else. I don't know.
Scale?
Scale. It could be a scale. Exactly. Perfect. It could be a scale. It could be other stuff.
Other fun activities.
Yeah, other fun activities. So now that I've given it a data type, I need to give it a name. So I will call it like position. Right? So now it has a name. That's great. Now I need to actually create it, because right now this is just saying, hey, I have an object, like I know what this needs to be, but I need to know like what it actually is. So I'm gonna say equals, and then I can type new, because I have to instantiate it from nothing. Vector3s are special in the fact that they have to be, they're not just like numbers. 1 is not always 1. A vector3 is not just a number. It is variable. It can change by a lot. So I'm gonna say new, and then Visual Studio already knows what I'm thinking. It's like, okay, you need to make a vector3, I can do that. So I'm just going to click enter. And then I need to feed it like, okay, what are the actual things that you're going to put into it, right? So in this case, I just need to fill it with an x, a y, and a z. And in this case, these are numbers, right? Same thing that are exactly here. So I have a position that is 315.86. That's probably where I'm probably going to put it. I don't have to be specific here. I'm just going to kind of wing it. So the first number is 315.8-ish. Now, something about Unity and a lot of programming languages is that numbers are not just numbers, right? They have to be, there's a lot of different types of numbers. So you could have integers, so that means 0, 1, 2, 3, 4, negative 86. Anything that is not actually a decimal. And you have floats, which are decimals, 84.860042, whatever. You have doubles, which are even bigger than floats. Like the number of data types for numbers is surprisingly large. The number of data types in general is just surprisingly large. So essentially, for Unity, you probably, if you're ever using decimals, you want to use floats, because floats are essentially decimal numbers. But when I write something just like this, Unity isn't going to see that as a float, it's going to see it as a double. Which you can use doubles, that's fine, but a lot of things don't like doubles. So it's in good habit to make sure that it's defined as a float. So by doing that, if I just press F after it, that's telling Unity that, hey, I want this to be a float, don't get mad, it's fine. That's my X coordinate. Now if I see this, you can see that it already is kind of understanding what I'm thinking of. It's like, okay, you want a Y vector? I can do that. So now how high do I want this object? Now, I could put it roughly at, so right now the center point of this cube is at 0.55. So I don't want to put my guy at 0.55 because he'll be in the center of this. So I could maybe raise him up to like 1.55. I don't know, just kind of winging it. 1.55, cool. Say comma, awesome. And then for the z, I'll just copy the z directly because that's just like this direction. You can see it from this vector. So that's 197.3. Cool, that's fine. 197.3 F. And then I'm gonna press semicolon because that's what you have to do. So now I have this position, right? That's awesome. So now if I want to instantiate my enemy, I can put him at this position. So in this case, I can just say once again instantiate, which is just a function, open parentheses. I want to fill it obviously with my enemy, and then comma. So now if I want to use another variable to send into it, I have to use a comma to say that this is not part of the same variable I'm sending in. This is a new thing that I'm sending. Same exact thing I did here. Comma, next one, comma, next one. So now I have, okay, it says it wants to transform our parent, but that's not the only thing it requires. If I press the down arrow, you can see that here is actually changing. Yes.
I'm going to stop you for just a second.
Mm-hmm.
There are some people talking in chat
Mm-hmm.
with me.
Mm-hmm.
They're saying if it's a pre-recorded, it's not pre-recorded. I am eating this pizza live.
Oh,
Also,
it's confusing.
Dean, would you like to have a slice of pizza? Would you like me to take over for a minute?
Sure.
Okay.
I'll eat some
try.
pizza.
I don't really know. I don't know a whole lot about C# code, but I will try my best.
My goodness.
Maybe if you just walk me through it.
Yeah, I can do that while I also.
Oh, apparently I need to do this. Come here.
What? What? What is it?
Somebody said slap him for proof.
Can somebody give me permission to slap AJ? Please? Please. No, I need permission. Please. Somebody do it. Come on. Come on. Somebody's got to do it. I believe. Chat. Your beard takes up all... No, hold on. Your beard takes up all the force. There we go. That's better. Got a good slap. Thank you. Just like, what are you doing?
Well,
I
No.
know. It's we are former fallens of our what? I don't
okay, so let's see.
I can help. I'll be back.
Okay, what were you doing with this instantiate enemy?
I wanted to actually put in the parameter of position as well.
Okay, so if I am
Back.
correct, guide me through, Dean.
So, comma, you're going to want to put in actually position as a variable. Yep. Then enter. And then comma. It's going to want something else too. So I think you can get away with this by using
Oh yeah,
that
yeah,
one. You're going to want this specific one. You're going to want
rotation.
rotation. Now, for the actual rotation, rotations are in quaternions, which is a
That's
whole
another
thing.
topic for another day.
Quaternions, for shortest version of quaternions ever, they're rotations. That's all that really matters. If you want to have the basic rotation, you type in quaternion.identity. That's a zeroed quaternion.
Cool.
Semicolon.
So if I can understand this correctly, we are instantiating an enemy with the variable of position, which is a vector 3 set to this value of x, y, and z. And then we are setting its rotation to a zeroed out quaternion. Basically means it's just going to be level. So when we start up the game, I'm going to
Should hopefully
save
place
it.
them above it.
I'm going to then go back to Unity. We're going to hit play.
Oh,
Well,
raise them high enough.
It didn't raise him high enough, but he is there. There is his head. You have placed a man's head.
Raise them
there.
up a little bit. Give them some
I'm
height.
going to raise him up like Josh Groban raises me up every. Swing to raise his Y value. Okay, I'll go with like a solid 7.0.
Nice.
7.64. Now let's see where he ends up going. That was way too high. Okay. 3.1415.
9. I can do it.
3.14159.
We can actually get pi on it.
Should I just set it equal to pi?
Do math.pi.
Math.pi.
Let's go.
Dean and I are just having fun at this point.
Yeah, we're
now.
just like, maybe this will be the perfect value. Just watch.
Well, not really.
That's perfect for me.
It's good enough for now. Okay. Otherwise, we'd just be here messing around with values for
Yeah.
the next
Now we
10
actually have
minutes.
to do something.
Yeah, doing something would be very important for our enemy to do. So now, after we've put it in the start, we've instantiated it. We need to give it something to do in the update.
Yep. Now, okay. So
Well,
this is where
should we modify the controller instead of the manager?
Yes. So
Okay.
this is where I can take over
that's-
again because this is where it gets fun.
Yes, Dean is going to take back over because he's finished eating his slice of pizza.
Do you want
Wasn't
your?
that fun?
Do you want
Oh,
your?
yes.
Well, I'll just
Oh, you
nibble.
didn't finish your slice
I'll
of
I'll
pizza.
nibble on it.
Okay.
It's okay. So yeah. So we have our object, right? But the problem is, hold on. Problem is that first off, it doesn't do anything. It doesn't move. And problem number two is that it isn't even moving towards us, and we only have one, and we have no other way of tracking it. So there's a lot of problems. But progress at the very least. So what we're gonna want to do now is we're gonna want a way to specifically like make a lot of these and know all of them, like know the positions of all of them. So this is where arrays are gonna come in handy. So arrays are just basically a giant list of objects. That's all they really are. They're just arrays. They're just a giant list of objects that are ordered. So, and they're also zero based, which means that the first index, the first guy is at index of 0, this one at 1, so on and so forth. So let me explain kind of how arrays work by just doing them. So what I'm also going to want here is I'm going to want some sort of array I can know what the heck I'm talking about. Now, there's no point in doing it in specifically, well, I could do it in specifically enemy manager because I guess we're here now, so it's fine. We'll do that. So I want to make this global, meaning that any function can access these variables. Because if I tried accessing position in this guy, it's thinking of image position, but that's just not right. Because this guy was only created in the start function, right? So he has no access to anything down here. So I don't want that. Give me my space back. There we go. So what we're going to do is we want to make a global variable so that way everyone in every function can access it. However, we don't necessarily need to have it be public. We don't need to have every single, class be able to reach it. So we'll just make it private, which means that only this class can actually see it. So I'll make it private, and then this basically needs to be a game object array. We need to know all the specific game objects in the specific thing. So we're going to say public game object. Now that would only be one, but we need to tell Unity I want this to be an array. I want this to be a list of game objects. So sorry about that. The way to do that is if you do the square bracket forward and back like that. This tells Unity, hey, this is an array. I am aware of this. And then I'll give it a name and I'll call it like enemy array. And do that. Cool. So now I have what's just basically a long list of specific stuff. I got that. It's all cool. So now that I have this array, I need to instantiate this array. That word again. It's almost like it's kind of how this whole language works.
Or something.
Yeah. So to make this array, I like to do this in Start because obviously it's a good place to do it because
Did you
starting.
mean to make it private game? Okay. You said public game.
Oh, I did.
Yeah.
Yeah. Private. I mean, with this thing,
What's the difference between public and private?
Public means that any other script anywhere could actually reach it. If I'm an enemy and I have a reference to the enemy manager, I can access this enemy, right?
Mm-hmm.
But if I'm in enemy script here and I'm trying to access enemy manager's enemy array, I cannot access this. I do not have access to it. It is private. It is locked into me. It's like, my whole thing. For the most part, I mean, it does definitely matter. But for the scale that we're talking about now, it's
Pretty minute.
It's minute. Minutia. So yeah, so we have this array, so we're going to instantiate it again. So we're going to say enemy array, which we have here, so that's the name of our variable, equals, once again, that's how you set things to do stuff. I want to say new, because I need to make it as, it needs to be created, new, and it's going to say a game object array. Now, with arrays, you have to specify how many slots there are for stuff. So if I wanted to have 10 enemies, I would have to say I want 10. That needs to be 10 things that are actually going to fill that. Now, you could change this number to 100, to 1,000, to 1,000,000 if you even really wanted to. But once that number is set, that's how many are in there. If you try to get the 11th guy out of that list, it's going to say, hey, I don't have access to that. That's out of my index. I can't do that. So you have to specify its length before you do anything. So we have that now, which is great, but now what we need to do is we need to go through, and the problem with arrays, and just this whole thing, not really a problem, but just a point of them, is that you have to fill each spot individually. You can't, it's a whole different thing, but for all intents and purposes, you can only fill one at a time. So we need a way, we could just go through and say, okay, enemy array, and this is how you access it, that just means like at what index, at 0, which is the first one, equals, this specific thing, equals our specific enemy. And then do it for 1, and then do it for 2, and then do it for 3, and do it for 4. But that's stupid. That's stupid. What if I had 1 million enemies, and that's just the way that my game works? I'm not going to
have 1 million lines of code.
Yeah, that's stupid. That's stupid. So there's a much more efficient way to do this, and it's called a for loop. For loops are great. I love them. They're just kind of weird when you first look at them out. So what a for loop is it basically is exactly what we're doing. It's an iteration. It just goes, it can iterate through as many times as you want it to go, and it's very structured. So you'll say, okay, I want to first go to 1, then 2, then 3, then 4, then 5, and 6. And the most important thing is that we'll have to finish that iteration before it moves on to the next line of code. So let me explain it. So if I do for, that's just the keyword for it. Open parenthesis. This is where it gets weird. I'm just going to write this whole thing out right now, and then I'll go back and explain it. I is going to be less than 10, and then I plus. Do that. Okay. I've written a lot of for loops in my life. This is really concerning. Yeah, so basically what this is that I'm declaring an integer. That's what int is. I'm just calling it I. That's just like a standard coding thing. You just call your integers I. At least for for loops, it's just what you do. And I'm telling it that it's equal to 0. So I'm starting with, that's going to be like almost like my counter. It's basically just 0. Then after that, we're going to say I. This is basically saying, when do I stop iterating? Because, I mean, I could just tell it to iterate forever and break the computer, or rather crash Unity. But I need to say, I only want to go 10 times because we only have 10 things in my array. I could tell it to do 100 if I wanted to, but for now, we don't really need to worry about that. I'm just making 10 things. And then what this I++ means is that plus universally means add 1 to it. So if I have a 0, add 1. I have 2,886, add 1, 2,887. Basically just that. Very simple. So that means that what's going to happen is this, whatever's in here, will be run once, and then once that thing finishes, it's going to loop back around. It's going to change this number to 1, and then it's going to do it again, and check it again. 2, 3, 4, 5, 6, 7, 8, 9, until this thing goes, once it's 10, when it does that, it's going to say, hey, wait a minute, I is not less, or, 10 is not less than 10, 10 is equal to 10, or 11 is not less than 10, it's greater than 10. I need to break out of this. So then it will stop, and it will move on to the next line of code, which is incredibly useful for if you want to fill something really quickly, or just, access an entire array. Arrays and for loops go hand in hand, really. So basically what we're going to want to do is we're going to want to, for, all of our objects, we're going to want to go through, give them a position, instantiate them into an actual object, and then put them in this array. So that way we can access them later. So the way we're going to do that is I can just directly drag this line of code. I'm going to pick it up, put it in here. All that good. And then I'm going to pick this guy up and put him in here. So this is a good start for it, because that means this thing will run 10 times. And I'll put a debug in here afterwards to show you that it is actually running 10 times. So we are getting a position. Now the problem with just using this instantiate thing is that we have no reference to what we're actually instantiating. We create it into being, but we have no way of actually accessing it once it's been created. So we need to give it a reference. So what we're going to do is, there's a little cheeky way of doing this, is I will just, let's do it like this. There we go. I like having spaces. It's good. I'm just going to create a game object, and I'll just call it, I spelled that. Nope, forgot the capital O. You got to be careful about that. And I'll just call it lowercase enemy, because the case actually does matter.
Yes.
And I'll say equals instantiate. So what this game object is just this essentially is just a reference to what this entire thing is. This guy equals this entire thing. It's very useful so I can actually place this enemy object, or rather this whole thing, into our actual array here. So that's why I'm just making a reference to that. So then once I have actually created this enemy and I've given it its position and such, then what I can do is I can say, okay, now I need to actually fill my array with the specific object. Okay, so then I can just say enemy array, which is the array that I specifically have, at, now this is the thing, you have to say, what spot do I want to fill this with? And this is the beauty of arrays. I need to first fill it at spot 0, then at spot 1, then at spot 2, then 3, then 4, then 5, 6, 7, 8, 9, right? Because everything's 0 based, there's only 10 slots total starting from 0, ending at 9, which is exactly what this I is doing. It starts at 0, goes through this entire thing, then becomes 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it stops. So if I just say enemy array at I, and then I say equals, and I can just put that at enemy, that means that the first spot will equal the first enemy, the second spot will equal the second enemy, the third spot will equal the third enemy, so on and so forth. So to actually give you a visual of what's actually happening, I'm going to put a debug in here. So I say debug.log. And if I just, the great thing about debug.log as well is that I can say, okay, put I in that. So what that means is that it'll actually display the value of I as it goes through this entire thing, which is super duper handy. So I'm going to see if this works. Should, hopefully. Now let's just make sure we're going to go check our enemy manager here, make sure there's nothing fancy in there. We're just going to press play. And you can see that, if I go to the console, you can see that this has happened 10 times. It starts with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and all that thing. And then also over in our hierarchy, you can see that we actually have 10 enemies. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So super duper useful for that. We can make 10 enemies. I could change it to 100 if I wanted to.
I'm going to do something really quick before we eventually break the game. Enemy script. Get rid of this. Actually, I'll just... So there's another handy feature when it comes to coding. It's called commenting. So by doing a simple //, all of a sudden this line of code no longer actually exists. It is merely there so that way when you're looking back through the code, you can say, oh hey, at some point, I wanted to say to myself that I had a debug log in here just to check if things were running correctly. This is handy, like if you're in a team and you are passing your code off to one person to another, and you want to indicate like, oh well, this code is specifically designed for this. This is designed to make the character move or to make enemies spawn. It's also really handy if you need to test, like if one aspect of your game is working, you can comment out another part of your game, and then you can get rid of this / and you can make it back in again, rather than simply like deleting the code and then having to re-input the code again. It's a really easy way of just comment. That's what it's hard. It's hard to come up with another word.
Yeah.
It's just you're commenting it out.
Unity does that by default, right? They gave you this thingy here, which just says update is called once per frame. It's in these two //, which means that the compiler, when it actually runs it, it's going to say, oh, I'm not going to look at this. This isn't actually going to be turned into real code. This is just for us humans to actually look at, so we know what's happening.
Us mere mortals.
Us mere mortals, right? But this was really important, right? But you might have also noticed something, that when I created all these people, it looks like there's still one guy. When in reality, if I go back to the scene view and I move my way out, if I grab, this guy specifically here and I scooch him out of the way, oh, there's another one and another one and another one. I just ripped off that guy's head. Yeah, but there's 10 of them, all just kind of stacked directly on top of each other. So that's kind of annoying to actually have them all just kind of stacked on top of each other. That's just a whole thing, right? I know I was gonna, yeah. So that's the thing that's kind of irksome, right? Is that we want to actually have them be at almost like a random position. So there's a lot of ways to do random positions in Unity. There's actually a very fun one, which I'm going to try and show, which is there's something you can do in Unity, which I've discovered, which is where you can basically take a sphere and then put a random position anywhere inside of that sphere, which is really useful if you want to have things that are all around you and you specifically want to have them somewhere inside of this giant sphere. So that way they won't all just appear directly on top of each other, because all of them are getting fed this very specific vector 3 here. They're all going at 315 at pi and so on and so forth. So what we're going to do here is I'm going to swap out position, because we don't need to have position at a very specific point. Because remember that the great thing about variables, right, is I could have just put in this value directly. But now, if I just have position and I change it up here, down here, it will also reflect that change, because it now has been officially changed. So there's a fantastic class in Unity called random. This is just a class that you have access to. It's built in from the Unity engine. If I say dot, there's actually something here called inside unit sphere. Isn't that such a handy dandy?
Such a handy tool.
Yeah, so you have that, right? So you have this inside random sphere, which if you look at this guy and you look at, I can't point with it with my mouse. Maybe I can.
Nope.
is that it's kind of hard to see, but there is actually a vector. It says on the left of the actual function, it says vector3. That means what it's actually returning back. So remember, functions can send stuff, they can return stuff. This is just returning a vector3. That's why it's not getting mad at me, because now my position is being set to that. Now here's the problem with this though. Inside unit circle is only inside at the 0. So right, it's saying that like, okay, if I'm putting the center of my sphere at 0, 0, 0, somewhere inside of a random sphere, that's going to cause two problems. One, they're going to be super duper close to each other, because the difference between, like, with a radius of 1, that's a very, very small circle. That's one problem. Two, it won't actually be placed in a proper location, because that's essentially going to mean that it's going to be at 0, 0, 0, and our player is not at 0, 0, 0. We are at, I don't even know what we're at.
Some weird value.
So we're at freaking over here with 300 or something.
301 and 191.
I did great setting up this scene, let me
Yep.
tell you. So that's a problem. So we can solve both those. The first one is you have to kind of understand vector math, which is just math is something you kind of have to start getting used to if you do code. It's just
It's an inevitability.
it's a thing you have to do. So vector math is not super difficult. It's just thinking about it like on a graph, right? So if I have a line that goes to 1, 1, and I want to make it bigger, if I just multiply both of those individual vectors times some sort of scalar like 5, it'll become 5, 5, which is 5 times bigger. Same concept applies here. I want to make this instead at 20. So it's, oh, that's D.
20. Yep.
It's 20 times as big now. So now the sphere that they can actually appear in is 20 times as big, which is great. So now I'll show you what happens now. If I do this and I directly put this in here, you're probably not going to see them. Yeah, you're not. But they are definitely still here. So if I click on this guy and I press F, you can see that they're all around here in this nice little sphere. But they're way the heck not in the right spot. They're at 0, 0, or roughly at this specific thing on this zeroing axis. But so we don't want that, right? We want them to actually appear next to us. So the way to do that, once again, vector math, is that all we need to do is just add our players, or I guess rather the enemies, which is where initially is going to spawn. We need to add the enemy's position to that. And when you add a position, like when you add two vectors together, it just basically takes the sum of them, obviously, because that's how adding works. But that works for vectors. So if I just do this, if I say position equals, now what I want to do is I want to make sure I add this position. So I want to say position, because that's where we're starting from. And then I want to add the enemy's position. If I say enemy, now this is only a game object, right? Oh, there's two ends.
Yeah.
Yeah, that's a thing. So remember that position is a vector 3, but enemy is a game object, and that just doesn't work. So what I can do is I can say dot, which gets you inside of that game object. I can say transform, which basically says what's its position, scale, and rotation. But now I need to know, okay, is
What
it
are you calling it?
in my position, or rotation, or scale? So I say dot again, and I can say position. By doing that, it's that position is a vector 3, and our position variable here is also vector 3, so they will add together perfectly fine. So if I do this, and then I specifically go back to here, and they should, quote unquote, should appear, they're all kind of around me. Or rather where the actual position was, which was about right where this column is. But you can see they're all just kind of appearing all around me. They're in a random position, which is awesome. So the cool thing is, the great thing about variables, right, is let's just say instead of 10, I wanted 500 of them. And then I'll just make 500 of them. And that's the great thing is I can eventually switch this number to a variable as well. So I can just have one variable that I change, and everything else beneath it gets changed, right? So if I press play, there should be around 500 of them. Is this gonna hurt the game a little bit? Yeah. But look how awesome that looks. You can actually kind of see the sphere that we have. Isn't it so exciting? We have crazy amounts of enemies, men, just all kind of running around in a nice little sphere. So yeah, this is just a really cool thing that you can actually do. You can see that our debug here, it shows, 400 or 500 of these specific things, which is cool. I'm going to bring that number down for now because that's just going to be a whole thing. I'll bring it to like 50. That's a respectable number.
It's a respectable number.
So now we have that. So that's awesome. They actually, specifically do that. But, so they still don't move though, and that's kind of annoying. So the basis of how movement works is you basically have to just move once per frame. You need to move the object a certain distance. Now, with enough frames, the movement looks normal. That's how our specific player movement works, right? Is that if I'm holding down the W key, it's taking my player's position and just scooching it forward by a certain amount, a crap ton of times.
Technical term, scooch.
Scoochy boops. But
Yep.
yeah, so we basically have that, and that's how we actually move. So we can do that exact same concept, but for all our objects, right? Now, this is why having them in an array is an incredibly useful thing, because otherwise, if we have to move all of our objects, we literally have to go to every single one out of 500 or 50 and say, okay, I want you to move this much distance, and you to move this much distance. But there's 500 of them, that's 500 lines of code, that's stupid. Coders are nothing if not lazy. That's the word. See, I couldn't even think of the word. That's how bad I was. So to reference all of them again, we'll need to use another for loop to actually get to all of them, because we have to iterate through the entirety of all 50 of them every frame to have them all move. So I can just do that same thing. I can say for. I'm going to basically copy the exact same thing I did up here. Int I equals 0. That's what we're starting with. I needs to be less than the actual number we have in our list or array, which is 50. Then we're going to iterate by 1 each time, which is great. So specifically, we have this as something, and now we just need to actually reference all of these enemies, right? So the way we can do that, I'm going to try to make it. This is an effective way to often do it, because normally you'd have to write out, if I want to access one enemy, I have to say enemy array at I, because that's the specific spot we're at, and then we have our game object dot transform dot position equals blah blah blah, and then we'd have to actually specifically move it. I could do that, or I could make my life way easier, and instead of writing out that entire line, I could just write out one line at the beginning and then just use that for the rest. So if I reference a transform, which once again, as we said, is a position, rotation, or scale, and I call that t, just for simplicity's sake, I could set that equal to enemy array at I, which is once again a game object, but we don't want the game object, we just want that game object specific transform, right? So we have that. So that means now, if I want to actually reference its position, I would just have to say t dot position, and then that's done. Equals, and I'm good to go. Saves me like I said, you don't have to do it this way, but I find it more efficient. Saves a little bit of time. I think it kind of makes it nicer looking too, rather than just having these super duper long lines all over the place. But more importantly, now we have position. So if I wanted to, I could do this. It'll look terrible, but I'm going to do it. So I could say t dot position, so the specific position for each individual guy. I could just say plus equals, which means that you take its position and add on top of it. I could say 0.0, that might be too little, 0.1 f. Now, I can't do that, right? Because that means that it's like, what the heck are you talking about? Because I'm trying to do a vector 3 to just a single float. Now, you could also just say dot x plus equals that. Now, the problem with doing that as well is that you can't just directly access a position's x value. You just can't do that. It's not something you can really just do. So what you're going to have to do instead is you'll have to actually make a vector 3 that you're setting its position to. So if I just said, okay, I'll make a vector 3, which is the variable. I'll call that new position, and I will set that equal to, let's just say, a new vector 3 that I'm now setting to 0, 0.1 f, right? And I have that, that's great. And then I could just say t dot position plus equals, and then new position. Because I can add two vectors together. That's something I can totally do. I'm allowed to do that by any regards. So what this should do, I put huge quotes on should, is that it should actually make it so every single frame they're going to move by this thing. It might look very jittery though, and I'll explain why if my point is actually true. They also might move really fast. Oh, but you can see they're all moving. Look at that go. They're all flying away at an equal rate, and it's kind of creepy because they look like they're...
Oh yeah, that's super creepy.
Yeah. But you can see that that's exactly how it is. Every single frame, so 60-something times per second, and they're moving by 0.1, and that gives the illusion like they're actually moving.
Really quick. How long have you been doing C# programming?
I started C# programming probably about a year and oh wait, no, it's only been it's been about a year and a half.
Year and a half.
About a year and a half, give
Almost
or take.
2.
I got a job working with someone at the university, and they were just like, "Hey, we need you to do Unity development." And I'm like, "I've never done it before, but I'll go for it." And ever since then, also my boss was like a really smart dude, so he explained to me all this stuff, and that's how I was able to figure it out. But
Michaela says summer before last. You did generally, I think.
yes, summer before last. It was
And then for our program, we had to learn ActionScript. So we did that for roughly about a year, and then we transitioned into Unity and C#, and we've been doing that ever since.
we've also
Dean has just taken it to an extreme level of he understands literally everything about it and decided to become Unity certified.
just pushing it.
Yeah, I know it's
I
pushing
find
it.
coding fun, and that might seem crazy to some people, but I write code for fun. That's
He has a lot of projects that he's started that just blow all of us away, and they blow our professors away to the point where it's just like you're making us look bad.
oh, not really. Anyways, beside that point,
back to the
back
code.
to the usually scheduled program. So that's great that we actually can move position, right? That's super useful that we're able to just move stuff all together. Now, problem is that we want to have them all move towards us as the player. Now, that's actually, you might think it like, I don't know if you think that's hard or easy. It's kind of somewhere in between. So the main difficulty is that you have to make them first off know where the player is. So we've dealt with this problem before because we first didn't deal with, okay, how do we know where the enemy is or what the enemy is? So we can do that exact same thing but solve that for the player. So I could just say public transform, because remember transform, just always think about transform when you're thinking of position, rotation, or scale. Mainly position because that's kind of the important one, but transform is just a way of getting where an object actually is. Not what it is, but where it is. So transform, and I could say player. Now, I know who I am, obviously. So if I look at enemy manager and I see the player, I can just drag my FPS controller, which is the player itself. I can drag that transform of it into here, which now says, now the enemy manager, which is our main script, knows who the player is, right? He knows that, okay, this player is at this position at this time with this rotation and this scale. Fantastic to actually know. We could debug.log it. I won't go through that because, it doesn't really solve a huge amount. But regardless, they know who we are now, which is awesome. Now, the difficult part is, okay, how do you know that if the player, I'm going to try, yep, that's too hard.
Yeah.
If the player is in one spot, how is the enemy going to know,
Where
one,
that spot is.
where that spot is, two, how far it is away, and three, what direction to actually go to get to that spot, and how fast? All of that can actually be solved with basically one function called a lerp, or a slurp. It doesn't matter. Slurp is still one of my favorite function names. Lerp stands for a linear interpolation, which means that between 2 points, if you were to go in a straight line between 2 points, that is the exact way that a lerp is actually doing it. Lerp specifically, you can look it up. That sounded really pretentious. I'm sorry. You can look it up. I mean, it's whatever. But no, so a lerp, the way that most codes do lerp is that, I'm sorry. Keep on getting distracted. Lerp is basically where you have at 0, you are at, actually no, I need to explain it because you need to do it like this. So what a lerp specifically is that it basically takes a value that is either 0 or 1, and it takes that value and it puts one vector between two others. Sounds super confusing. Let me just hear me out, okay?
Just do it.
Here we go. So if I want to have this new position, right? I need to first know, I can do something called a vector3, which is our data type, but data types also have functions built into them. So vector3.lerp, you'll see it's built in here. Oh dear. Lerp, if I say this, you'll see that it takes 2 vectors and 1 float called t. We'll come to that t in a moment. The vectors that needs to interpolate to, because lerp is based on 2 vectors, right? It has a start vector and an end vector. Where do I start and where do I end? In our cases, we need to start at our object's specific location, right? Because we're starting from wherever our enemy is and we're trying to go to wherever the player is. So we need to start our enemy, so that's just t, which is our enemy's position, or rather our holder of our position, rotation, and scale, dot position. So that's one vector. Now we need the second vector. The second vector is wherever the player is. So the player, as you saw up here, we defined it right there. So I can just say player dot position. So that means that's our player's position. So now we have the two vectors we're going in. Now we need to know how much we need to go in between the two of them. Because we obviously, since we know both of them, we're just trying to pretend like we're drawing a straight line between the two of them. And where do I actually go on that straight line? So
Because we all know that the shortest distance between 2 points.
is a straight line.
Oh, is it? I knew that.
Anyways, so now lerps, if I were to the idea of this is that if I were to put in 0 into this specific spot, like if I did 0f, that means that essentially if I were to do this, I can even show you this, they shouldn't move because their positions are themselves, which means they're always just stuck at their own positions, right? Actually, they all just kind of just, oh, I didn't set something. Oh no.
Oh,
no. Oh, you've discovered what errors are now. Oh goodness. Oh goodness
That's
me.
wonderful looking.
That's a new one. I'm excited about
Oh,
that.
it's because you just have.
Yeah,
this
because
in
it just flew in. Don't worry about that. Let's see if that'll actually fix it. I'll see if that is. If not, then I'm not sure if you're actually.
Oh, there you go.
There we go. Okay. You just saw what happens when you get an error. That's an unusually scary one, but that's fine. Anyways, you'll notice that they're not moving, right? And I'll explain the reason why the error happened too. Essentially, you'll realize that since they're not moving, it's because in our actual lerp function, 0 means that this is 0 essentially, our t.position, and then this is 1. So at 0, they're just at their own position, and if I'm saying their new position to their old position, I haven't moved anything. It's like setting 1 to 1. It doesn't do anything. The reason it broke, I'm assuming, is because I had plus equals, which means I just took 0. I took its own position and added it about a bajillion times until I basically I was doubling and doubling and doubling and doubling and doubling until I got to some infinitesimally enormous number, which is not good to do. So we're just saying it directly equal to now because the lerp is dealing with all that back end of how do I actually interpolate between two vectors. That's kind of complicated math, but we don't have to worry about that. So you'll see now if I do 0.5, they'll be like halfway-ish towards me. Some of them will be halfway-ish towards me. They might even be in a congealed ball. Oh goodness! Oh goodness! They also fly towards you too. I kind of forgot about that because they'll always be halfway towards me. Oh my. But that's not what we want either, right? Because that means they're still just like kind of ish close because they're always getting halfway and more halfway and halfway and halfway. So remember that it's. I really wish I had a whiteboard drawn because that would make so much more sense.
I'll get you one next week.
Okay. So essentially, the reason that those were flying at me is because, think about it. I don't know if anyone's ever heard of, I don't know if it's Achilles. I think it's the Achilles one, where it's essentially like he has a race to go, and each second he goes half the distance towards the race. So he goes halfway, which is at 0.5, and then 0.25, and then 0.125, and so on and so on and so on. So he keeps on getting halfway. So he'll like never technically get there because he's always going half of the distance to the race.
It's differential math.
Yes, it's kind of like that. So that's essentially what was happening here is that it got close to me, and then it saw, okay, now that I'm here, the halfway point is different now, so I can move forward again. And then it kept on pushing me, which meant that the distance increased again, and they kept on doing that. So that's the basis of how we're actually going to do this next part. So we need to have it move gently, right? We don't want it just to fly at you. You don't want it to be jittery. So the way that you can do this is there's a property called time.delta time. Now what this is delta time measures the time between two frames. Now there's kind of some complicated math, I'm pretty sure, of why you need to use this, but it's very useful for one, if your frame rate dips, time.delta time will reflect that. So if you're down to 1 frame per second, time.delta time will be 1. It'll be 1 second has passed between two frames. But if you're at 60 FPS, it'll be a super duper small number. So it's very, very effective for actually moving things because that means every single frame, the movement is representative of how quickly the frames actually go.
The halfway thing is Zeno's.
That's what it was. It was Zeno.
Not Achilles.
Oh, Achilles has a race thingy. I swear to goodness.
Yeah, but he also has a tendon.
Well, okay, that's your opinion.
I mean, I have two of them.
Well, that's your opinion.
Okay.
That's your opinion. Anyways,
What's the difference between time.time and time.delta time?
so
Because I know delta time is the difference between two frames.
So how long it takes from one frame to get to the other frame. Time is just counter. It goes 1, 2.
The
3.
internal clock,
It's
I
just
guess, of your computer.
it's literally the internal clock. All it is just counting up the entire time. Time is very useful if you're doing like something with sine or cosine, because that means you just have a time that actually is very consistent.
Okay.
It can go like that.
So you would never want to use delta time if you're reflecting on like a curve like that.
You could,
because the delta time would fluctuate.
Yeah, the delta time. I can debug it. It looks crazy. It just is like constantly going up and down.
Yeah, don't worry about it.
Yeah. So you'll see if I do this, they probably will still move fairly fast because we're running at a decently high-ish frame rate. But you can see they're all flying towards me, which is actually, and they kind of form this creepy congealed ball. Actually, like
They eventually become one large man.
yeah, they become one large man. But you can see that if I run this way and I sprint this direction and turn back around, he's still following me. But he'll slowly start getting closer to me and he'll push me through the floor. I've just made a game. There we go. But
Oh, in the story, a tortoise challenges Achilles to a race.
see, Keegan knows what I'm talking about. Yeah, so he specifically has that, which is very, very useful. Now the cool thing is let's just say, for sake of argument, that, but I mean, like, actually, before I do that, first off, you should just say, like, this is a fair amount of code. I mean, this is, 42 lines of code plus some stuff over here. Like, this is a fair amount of stuff, and, this isn't like crazy, but it's a very, very good start. There's a lot you can do with this. So that's one problem I've just discovered is that they come at me really quickly and they swarm me, and it's really quite creepy, actually. They form one very large man. But I mean, this could be brought into a lot of different uses, right? Is that you could have stuff following you. That's super duper common as far as how a lot of stuff works. So let's just say, though, that maybe you want enemies to have variable speeds. You want some enemies to be really, really fast and to be really, really slow. But you want that to be different for each one. You can do that. That's actually a very easy, no, not super, mostly easy. So what we want to do is we want to have, remember, all of our guys are inheriting this enemy script, which currently is empty. There's nothing really in it, because this is the reason why, is that you can have all of them inherit this same script, but then the script can do different things. So let's just say I have a public variable, which means that anybody can access it. Public, I'll call it a float, and I will call it speed. And specifically what I'm going to do to make this interesting is that I'm going to say speed. When the game initially starts, I want to set this to a random value. A random value between a certain range. So I can say random, great function, or rather class, dot, you can say range, don't you worry about that one. And you can set a minimum and maximum. So let's just say I put that between 0.5 and 0.5, nailed it. 0.5 and 1.5. Which means that some of them move really fast, some of them move kind of slow. We'll just do that. In fact, you know what? I'm actually going to make it way slower because I feel like they're already they kind of...
0.1.
0.1 and 0.5. No, that's too much. 0.9. Okay, so we have that, right? So we have this speed that we're specifically setting as a range, which is awesome. So we have that. Now we just need to actually reference that specific thing. Because right now our speed, not specifically here, down here, our speed is no longer in here right now. There's no way you think you can directly modify it. But the actual direct modifier of speed is your time.delta time. Because if that number is smaller, that means that they move in smaller chunks towards you. So let's just say I'm going to multiply this times 0.25f, right? That means that every frame they should be 4 times slower or a quarter fast. So now if I specifically do it, they all move at me kind of in a slower rate, right? Which is really cool. Same thing if I were to get them to a higher number, it would be bigger. So I'm just basically applying a sort of pseudo-random scalar to the specific end of the time. So if I want to actually reference, though, this enemy script, I have it. It's all here, I just have to access it. So here comes the fun part of actually doing all this stuff. So this is where components really come to handy. So remember what components are. Components are just like, if I have a light is a component. A plane, mesh filter is a component.
The collider. is a
Colliders,
component.
everything is components. Scripts are components.
The transform is a component.
Exactly. Most anything that isn't just the raw game object itself is a component. So what I can do is I can actually access the specific components from an object. Now, I think you can do it this way. If this way doesn't work, we'll find a different way, but I'm pretty sure you can do this. So I have my T, which is the transform of my enemy array, right? What I actually really want to do, I'll just do it this way. This way is a little more simple. I just need to grab my specific enemy array, which is just the object in and of itself. So basically what I'm going to be doing is if I press play, oh god, okay. If I'm going to basically be, you can actually see right now, you can see how the speed is actually already variable. If I go through any one of these guys, it's just some random number, which is great. So if I specifically want to access this speed that I'm setting here, I need to go into my game object, which is this, and say grab this component and grab this speed, which I can do. So let's just say I make a float. I'm going to call it speed, so I'm just declaring a variable, nice and simple. I'm going to say equals. If I do enemy array at I, which is the specific object that I was just talking about, then I can say dot, which says get everything specifically inside of it. So like all these parts that are, make it what it is. I say get component, which is just going to grab any component that I specifically ask. This one has some unique format. You have to use a caret and then say the component you want. In our case, that is the name of our class, right? I want an enemy script component, just like I want a light component. I want a mesh renderer component. So I want a enemy script component, and then I'm going to say open close parentheses. That's just what you have to do. It's still mad at me because it's like, hey, that's not a float. But I'm like, chill, we got this.
I know what I'm doing.
I can say dot, and then I can grab the actual things that are inside of this script. In which case that will be speed. Which, hey, look, a variable we just made is now visible here. So I press this, and then say end semicolon. Now I have a speed that I can.
Because it's public.
Because it's public. If I, however, went back to here and switched this guy to private, and then did this, and then went back to here, if you give it a little bit of time, you'll probably say, hey,
I don't know what that is.
it's inaccessible due to protection level. It's almost like this is private. So, switch it back to public, it's able to be seen, it's all good to go.
Working example of the difference between public and private.
Now, if you want to do, just for its general practice, you really do want to try not to have every variable public. That is proper way to do things. Public makes things easier sometimes, but there are better ways to actually go through and grab code because you don't want people to go in and be like, I'm just going to switch speed to 8,000 because I can. You do want things to be kind of behind closed doors, but for the purposes of just beginning learning it, it's not that big of a deal as far to get. You'll get a lot better as you start to kind of play around with it. But anyways, we have speed. So now all we need to do is just actually have the speed affect gameplay. So like we said, we're going to apply speed as like a scalar onto speed. So we have speed just like that. And then now if I go into the actual game, not get eaten by scary men. You can see that some of them are actually faster than others. Normally they congealed into a ball, but now the ball is congealing much slower. You see that they have kind of like a Congo line going right now. It's really quite exciting. It's kind of just getting in line. But you can see like this is kind of how. Oh, that's really weird actually. Love it. But so you could do like speed is just one component that you specifically have, but you could do health as a property rather. Sorry, not component as a property. You could have a plethora of different things as specific components. We could have starting rotation as a property of it. We could do a bunch of different kind of stuff like that. So that is just kind of the raw basics of what I was trying to think of showing today. I mean, we could do a bunch of other stuff with it as well, but this is just kind of the basic stuff. So just going back through the whole thing very quickly now. We start with our main enemy script, which is attached to each enemy. It's got a public variable that we can access from our manager. In the start function, where specifically, which happens when you press play, we're setting the speed to a random value between 0 and 1. And then in our enemy manager, which is actually, controlling all of the enemies, we have a reference to which enemy we're want to create a bunch of, and a reference to where the player is. We've also created an array that we can fill up with all the evil enemies that we actually are going to have. Then in the start, we're instantiating this array, giving it a specific length that we specifically want. That being 50, it's an arbitrary number, it could be 87, who cares? Then with this for loop, we're iterating. So we're going through each individual section. We're getting a random position inside of a sphere, multiplying it by a scalar so they're not just all congealed into a small ball. Then we're setting its position equal to the position of our inside sphere plus the position of our enemy to make sure it actually is put in the correct spot. And then we're taking a game object of our enemy, which we are now as a reference to the actual creation of the enemy at the position we've decided in the quaternion, which is basically just a starting rotation, and then filling our specific array with that enemy we just created, and we're doing that 50 times. It's awesome. Then every single frame, we're iterating through our entire array of enemies, and we're grabbing a reference to their transform, so their position, rotation, scale, and then we're getting that specific variable that we initially defined here by grabbing that specific enemy, grabbing its component, getting the script from it, and then grabbing its speed. Then we're actually defining its new position where it's going to go to try to get to the player by doing a lerp, which is just an interpolation linearly between 2 points. And those 2 points being the actual enemy's position and then the player's position, and then we're doing that by the time it takes between each frame times the speed that we previously defined, so it looks, and they have variable speeds, and then we're just directly setting that position of that enemy to that new position, and thus we get Majesty.
How difficult would it be to make the enemies face you?
That would not
rotate.
That would not be horrible, I'm pretty sure.
Victory Hub wants to know.
So the way that you can do this is there is a function in transform which is called lookat. Now the only problem with transform.lookat is that, so remember with vectors, vectors actually have, or rather with transforms actually, I'm sorry. Transforms have actually defined forward, right, and up. Forward is that blue vector where it says like this is where I'm looking. That's what the transform thinks is forward. Up is up. Right is right. Now those aren't always perfect. So what we can do, there is a function in here which we could do through each one. We could try to say, okay, I want to say t dot. I think it's just lookat. Yes, lookat, which says, okay, I want you to. It rotates the transform towards the forward vector. So basically, it says that its forward vector is looking at the specific transform target. Our transform target we're looking at is our player's position. So I just type in player here. That means just because we're just looking at a transform. So I don't know if this is going to work. I have very seldom used lookat, but let's find
We're
out.
about to find out. Nope.
Well,
Weird.
so you can see this is the problem we're talking about, right? Is that they actually are looking at me, but it's because the fact that their forward vector is believed to be to the right. It just kind of has its forward vector wrong. So this is the kind of tricky part when it comes to rotations, is because the rotations of it thinks it's looking at the right spot, when in reality it's kind of not. There might be an overload that can fix us here. Let's just see. You can tell it to look at the position. You can tell it to look at the world up. Position world up. Yeah, that's a bit tricky to actually get work. I suppose we could just, maybe we could fix the prefab. We might just be able to fix the prefab to kind of fix that. That might actually be, I should probably keep that down. So let's just look at our prefabs. So here's actually a really good note in prefabs, right? So let's just say I want to change how this end, yeah. So you can actually see it right here, right? So this is the blue vector. That is actually its forward vector. So we could just cheat and take this guy and then rotate that 90 degrees and then scooch that over this way. This guy, nope, this guy, that about that 90 degrees, and then scooch that forward, and then take this, and then that doesn't even need to be rotated. No. Have it hunch like it was before and save that. So now you're thinking like, okay, then how do we actually apply this, all these changes that I made? For a prefab, if you look in the inspector, there's these select, revert, apply. If I press apply, that means that all the other prefabs now, if I drag them out, you can see that they've actually been pointing towards the forward vector. So hopefully, once again, hopefully, we'll see if they actually will look at you going forward. There we go. Look at
That's
us go.
terrifying.
So now they're all just kind of flying towards you with their hands going forward. So that is most of the time, if you're dealing with a rotation, if you can deal with it not in code, that's probably better. But no guarantee. The transform.looat's a very useful function. There's also a quaternion function that I think does something similar. But quaternions, that's a whole day is talking about how that works. That's when I need the whiteboard. But
Now we have a real Congo line.
yeah, we got a real Congo line. We're all playing forward. But it's kind of cool. You can kind of see that no matter where I go, they'll always look at me like this, which is on one hand very creepy, but on the other hand very nice.
Dean, I know we're running out of time, but really quick, this is mainly my question.
Mm-hmm.
How do we make them collide with the ground and collide with each other?
So the problem with this collision, right? Well, actually, it's not hard. The thing is, though, we have to give them rigid bodies, right?
Yes.
So if I were to
we
go,
just apply that to the prefab.
well, here's the thing: is that if we actually just make them, if we give this specific thing a rigid body, it won't do anything because it has to be on actual a mesh, right?
Yeah.
So if I were to give the head a rigid body, well, this will be funny. Also, go away. I look for rigid body and give it that, and I give it gravity, and it's not kinematic and stuff like that.
Yeah.
Basically, if I say apply, all the heads are just gonna fall off. And worst off, their transforms are still in there, so they'll actually keep on following me. So even if I turn my head, you'll see they all kind of spin with me. Because remember, they're still parented underneath their, the enemy, which is the thing. They even jump, which is actually hilarious, because they're looking upward. And they kind of bounce and stuff like that. So right now, I didn't deal with collision because movement is actually a little bit of a tricky one, because everything has to be kinematic for it to work. To actually make them not avoid these specific pillars as well, we'd have to do with pathfinding, and that's a whole other can of worms that I don't even fully understand.
But what happens if you turn on the kinematic?
If I turn on kinematic, what will probably happen is, well, they might collide with each other, though honestly, since they're kinematic, they probably won't. Because kinematic just says, I don't really care. Oh my.
Oh my.
And oh god. Yeah, you can see that they don't really care. It's just because they're all getting crunched together regardless, and kinematic just says, hey, I really don't want you to go. I also never applied that because I'm silly. There we go. I was wondering why the head still fell. There we go. So now they're just kind of stuck onto me. So I will collide with them, but they'll still kind of merge into each other.
Oh, okay.
Just because they're kinematics, they're kind of forcing themselves to do it. It's against their very will. But yeah. We'd have to actually deal with the whole movement script. But here's the great thing about enemy though, right? Is that the great thing about doing it this way is that if I wanted to give them any specific controls, I could move all of their controls. Specifically, like when I was testing this, that's what I did is I moved all of their actual movement into their actual enemy script, right? Because that means that if I just modify the enemy script, all of them will actually be affected by that exact same thing. So that's the very effective way of actually doing that. It's the more proper way. With my old enemy script, which I'll just show you. I just made a function called go after player, and I sent in the actual player location, and I had it lerp that exact same way we did it, and pretty much the exact same thing. My old little test here. It's basically the exact same thing, but I'm just getting a reference to the specific enemy script itself. Telling it to go after the player.
Okay.
So, yeah. Is there anything else?
We're gonna leave it open for questions for just a little bit.
Coolio.
So if anybody has any more questions that they want answered, we'll try to get that answered within the next couple minutes. Otherwise, we're gonna try to wrap it up here in a couple minutes.
Yep, I'm gonna eat my pizza.
Dean's gonna finish off eating his pizza.
Mm.
I'm just gonna mess around in the Unity scene and just wait for any questions that might want to appear. So maybe we'll just get rid of this enemy because it was just a prefab. The Jake Badlands has asked us.
Hold on. For Jake Badlands, how to make your scene less spooky. This is specifically for Jake Badlands. Well, even specifically for Jake Badlands, Jake Badlands, you're in too deep. It's not going to be unspooked. You're just kind of screwed. You're going to have to wait until next Halloween to maybe dispel that. But until then, I don't think you can be doing any development, unfortunately. Or just, get rid of fog. Actually add a light to the scene. Maybe don't make stuff flicker. Don't have spooky ghosts as models. Maybe walk faster. Allow yourself to actually defend yourself in some regard. Other than that, yeah, you're screwed. Oh yeah, yeah.
Emote. We need maximum spoopage. I mean, we could just make it kind of spoopy really quick right now. I could go into the window, and I could go to lighting, settings. I could get rid of the skybox. Make the ambient color just black, and then give it fog. And make it 0.05. Make it gray. And get rid of the directional light.
Then we can't see anything.
Yeah, and then
That's the point, right?
Yep, maximum spoopage. Then we'll give ourselves just a small area light. With the width set to 500.
Area lights are actually I wouldn't use area lights.
No area lights? Alright, never mind. I don't know lighting very well. How would I make a 3D object's material glow?
Oh, I can do it. So, material glowing is something called emission. It's in the material of an object. Specifically, there's something, if you look right... Do you have any spare materials?
No, we don't. I don't.
Wait, one right there. Yep. Spooky.
Oh, spooky.
So, if you look right here, there's something called emission. If you click on that, you can actually set a ball to have a specific type of emission. Now, the problem with emission is that emission, if you want it to look good, if you want to actually light the scenery, it needs to be baked. Which baking lighting is a whole different subject, but for baking lighting, that means that you predefine how the light is already going to work before you actually run the game to make lighting look better. So you basically just like bake it, is the term. You bake it into the actual, mesh itself. Yeah, so that way you know exactly what it looks like before you have to run, so you don't do it a hand. The advantage is that light can look so much better. The disadvantage is that it doesn't look good. No, don't put your computer in the oven. Oh, no, you silly goose. Silly Willy. But yeah, the emission is a way to do that. It can at the very least make the object look bright. And if you add bloom effects to your actual camera, they'll actually affect that. But as for physically lighting the scene, you'll need to be... You can't do that. But, or maybe you can. There might be some clever shaders that do it, but... I honestly don't know a huge amount about emission. I actually tried doing emission recently and failed and then had it work just magically, so I'm not exactly an expert on that. Yeah.
So any more questions?
Anything else?
If not, we're gonna wrap this up because it's 10 o'clock here. Dean and I are tired.
Let's go.
And there's 2 more pieces of pizza sitting there that need to be put in our bellies. Nothing to be embarrassed about here. Nope, no siree. So yeah.
Should we have a signing out song?
Can I come by and eat the pizza? No. I'm sorry. But that's our pizza. Well, if that is all for questions, we are gonna head out.
Yep.
Thanks for watching, everyone. Next week we'll be back with another exciting episode of Tishin Tuesdays, where Dean and I will probably go over the basics of shader code, maybe?